Hello, everyone. I'm going to be talking about the end of the world. Now, that is arguably a pretty gloomy topic. So I would like to start by saying that I'm by nature actually an optimist. And we live, however, in arguably difficult times for optimists. And the reason for this, of course, that we all know by now that we will not be able to prevent global warming by 2 degrees. And we also know that these 2 degrees are actually quite important and will be likely a tipping point of climate. So we know that there are quite challenging times ahead for all of us. And, well, it's difficult to be an optimist during these times. I think there's a certain feeling of doom and gloom in my generation and of all the ones that are coming afterwards. Because the question is, how do we face these times that are ahead of us? There is, of course, denial, arguably the worst attitude. There's also despair. And I feel a lot of us are facing the climate change ahead of us with a feeling of despair. However, as I said, I'm an optimist by nature. And I want to offer you today a perspective towards climate change that maybe allows for a little bit of optimism for these challenging times ahead of us. Now, my optimism also has something to do with the kind of field that I'm working in. I'm a scientist. And as you can see, I'm an astrobiologist. Now, astrobiologists study aliens. And as you might be aware, there's a little bit of a problem with that because we actually haven't found them yet. So optimism is very good if you're an astrobiologist. So personally, I'm quite optimistic that the place where we might find microbes that are the alien microbes will be on Mars. And as it's very difficult for us to go to Mars, we can send robots there. One of the best places to study microbes that we might find on Mars is to go to the most Mars-like places that we can find on Earth. And for example, they look like something like this. This is the Atacama Desert in Chile. This is a salt lake next to a volcano, also in the Atacama Desert. And this is a little bit closer to home. This is the Kaidan Basin in Western China. All of these places are very high altitude usually, quite cold, very, very dry. As you can see, there's not obviously any life around. There are no plants, no animals. There's not even like birds or anything like this. And the reason for this is that these environments are extremely challenging. So the only life that you find there are microbes. And these microbes are toughing it out in arguably very harsh conditions, but they're doing it in very surprising ways. And this is what makes us quite optimistic about maybe finding them on a place like this, on Mars. However, I'm not going to be talking about Mars to you today. Instead, I will be talking about Earth. So the interesting thing about if we talk, so this is again like as a thing I go out into the field, and then I collect some microbes and I put them in the lab and I put them all through a horrifying regime of lasers and like targeting them with X-rays and deep freezing them and all the mad scientist stuff that you usually do, so that I can find out that they tell me most about what they do and how they survive in these harsh environments. All right. However, as I said, I'm not going to be talking about aliens so much today because I want to talk about Earth and life on Earth. Because there's something quite nice about being an astrobiologist. You combine 2 very complex disciplines that, however, offer a very big perspective. On one side, you have space. On the other one, you have life. And both of those are great for getting a healthy sense of perspective, along with some humility. So today, I'm going to take you on a little bit of a journey. So put on your seatbelts, get comfy in your seats, because we're going on a little bit of an interstellar adventure. And we're going to go planet hopping. And I'm going to introduce a little bit of a variety of planets to you and what we know about them and what we know about the life on them. So let's go to the first planet. Oh, well, that's the planet that we live on right now. This is the harsh thing that we are facing, but let's see what it has to do with climate change. So this is the first planet that we're going to. As you can already see from orbit, it has a little bit of a hazy layer that is of methane. It has an orange tint to it. And the interesting thing about this planet is it's actually quite young. It's only a couple of 100 million years old, which as far as planets go is very young, trust me on that. It's also quite active with volcanoes because it is so young. It's full of volcanoes. Meteors strike it basically every Tuesday. So it is a little bit of a hellish landscape. And before we land on this planet, I have to warn you, the atmosphere is terrible. There's absolutely no oxygen. So please put on your spacesuits before you step out. All right. let's land and let's have a look around. This is what we see. As promised, a lot of volcanoes around, a lot of meteorites. You also see a huge moon in the sky. The moon is actually quite large, but it's also very, very close, and is almost as new as the planet. You can also see there's some lava lakes, there are also some volcanoes on that moon. And the moon is, as I said, very dramatic in that sky. The interesting about this hellish landscape is, although we can't breathe, and I would never want to live on this kind of planet, is that there's already life on it. Not exactly at this location, but a little bit further away, there is an ocean. And within that ocean, there is already life. So life seems to be not too choosy about how cozy the environment has to be. It can even live on a planet as hellish as this. But okay, let's go to another one, a little bit more amiable world. Let's go to this one. So you can already see from orbit, you don't really obviously see any continents. And that's because this planet is basically almost entirely covered by water. There are some islands there made by volcanoes, and we can have a look what the planet looks like from there. So let's set down on a little shore, somewhere maybe where the sun is setting. This is a little beach where we find ourselves in. It almost looks like a beach today on Earth. You can see it has like very nice clouds in the sky. It is like a little bit like a bluish sky. The ocean has a little bit of an orange tint to it. There are also very interesting and dramatic tides on this planet because it also has a moon that is a little bit too close. It also spins quite fast. It has a little bit less than 24 hours that you're used to. But as you step out with your spacesuit, I warn you again, please put it on because there's no oxygen in the atmosphere. Otherwise, you would asphyxiate. But as you step out and walk around the little shore, you see something interesting. There are some small patches that almost look like jelly. They're red, they're purple, and they're green. And even the rocks are coated with a weird, slimy substance. And that is actually part of the life that this planet is teeming with. The oceans are filled with all kinds of different sorts of microbial life. Again, no plants, no animals. It's a very quiet planet, but just full of life. All right. Let's go back into the spaceship and let's go to one more planet. Let's go to this one. Now from orbit you can already see it's basically completely covered by a layer of ice. As expected, the average temperatures on this planet are quite low, and there's ice even at the equator, even in the tropics, where you would usually assume the temperatures would be a little bit warmer. Now this planet, interestingly, does have some oxygen, so let's land down and have a look. As you stepped out, this is pretty much what we were expected to see, ice everywhere. When you take off your spacesuit helmet to breathe in a little bit of the air, you notice there is oxygen, but it's much less. It would be nice. It actually feels like if you're on a very tall mountain. There are also very strong winds around. It's very cold. You see there's some little patches of red and green underneath the ice, but otherwise there's nothing too spectacular to see here. I tell you again, this planet does have life, but it's not very obvious from the site that we landed on. All right, let's go back into this warm spaceship and let's go back home. Now, the interesting thing about all the 3 planets that we've been to before is that I'm a little bit of a liar, because I told you that I would take you on an interstellar adventure in my spaceship, but actually I was completely lying to you because you never left home at all. We were all on the same planet for the entire time. And what I present to you as a spaceship was in fact a time machine. Every single one of these planets was Earth at different points of its long, long history. It was all the same planet all along. Now, when we think about Earth history, we usually think of dinosaurs. And that is completely fine because dinosaurs are really cool. However, it's not always good to get an accurate sense of scale of the true history and the true age of the planet if we're presented with something like this, where we have dinosaurs in the middle and then fishes and stuff before, and a little thin layer of, well, other stuff that came before. Because as you can see at the top it says millions of years, at the bottom it says billions of years, and there's a very big difference between a million years and a billion years. However, as most people, it is difficult for us to grasp really large numbers. It's also for me really difficult to understand intuitively what the difference between a million and a billion years means. So let's maybe compress all of that time into a time span that we are more familiar with. Let's all put the entire history of Earth into the span of 1 year. Now, if we would compress all of the 4.6 billion years of Earth into 1 year, into the 365 days we're familiar with, it would mean that every day would be 12.5 million years old, and 1 second would be around 140 years. So if you blink, you've already missed 100 years going by like this. However, it's nice to have a scale like this because it's a little bit easier to understand the scale of things. The year starts very strong. This is like our history of the Earth in 1 year. And we start very strong with the formation of Earth on the 1st of January, of course. Then a couple of days later, on the 9th of January, a giant planet hits the Earth and the moon forms. It's a pretty brutal and violent event, as you can imagine. However, the rest of January is pretty interesting. Because if you remember the planet that we went to, the first one with all the volcanoes and all of that, this is exactly what Earth looked like during the very first chapter of its journey. And there's something else that's interesting about this very early, very young and angry world. Because if you remember, I told you that there's an ocean. And in the ocean, there's something alive. And the thing that's alive in that ocean is something that has a sort of personal connection for all of us. If you have cousins, you know that you share like a grandparent, like grandparents, a couple of grandparents with your cousins, right? You will have the same grandmother, the same grandfather. Now, the interesting thing about life on Earth is that we're all one big family, because all of Earth and all of life alive today on Earth is interconnected. You are basically distant cousins with your cat, and even more distant cousins with your houseplant. And if you had a bacterial infection, you were also distant cousins with that. So basically, every conflict ever, every bacterial infection, every cockroach infestation was just a family conflict, in a sense. So the interesting thing about cousins is, of course, that, again, you share like a set of grandparents. And the set of grandparents we all share, everything alive today, was alive during this time. We gave it a nickname. It's called Luca, the last universal common ancestor. And the nice thing is we do know a little bit of Luca because we all carry a part of it in us, in our genes. If we take the genes of everything alive today and we put it in a big computer and we compare how like similar those genes are, we can compute back the earliest one before it all diverged. And that's Luca. Like grandparents, of course, Luca was not the first life around. Your grandfather wasn't the first person to ever live. There were other cells that came before it. It also wasn't the only one. Your grandfather also had other people alive at the same time that you're not related to. So Luca was just one cell of many living in a big ocean teeming with life. All right. This was the planet it lived on, so Luca was also pretty tough, I would say. Now, what else happened in this year? You might be wondering, when can we expect the first animals? Now, right now, we are having February, so you will still need a little bit of patience to still see the first worms crawling around, because the first animals will only appear in the middle of November. And if you look forward to see some dinosaurs, you will need even more patience, because the dinosaurs only make their appearance after the middle of December, and then, of course, they end dramatically with the impact of the meteor that killed the dinosaurs on the 26th of December. If you're looking forward towards the emergence of humanity, you will need even more patience, because we only make our first appearance on the very last hour of the last day of the year. And if you blink during the last second of the year, you will miss all of the history of Hong Kong and the British colony. Now, what happened in the entire middle in between this? What happened between, here we are. What happened in the entire middle between February to November? The Earth was already there. There was already life around. What was going on during this time? This seems to be a pretty big time for nothing to be happening here. Well, the interesting thing is, during all this time, this was a planet of the microbes. So the only life alive during this time were microbes, but there was a lot of them. And something pretty interesting and dramatic also happened during the midpoint of the year, around June. Because Earth, around this time, was going through a little bit of a midlife crisis. Remember the second planet we went to, the water world with the nice beach? Let's go back to this planet for a moment, and let's step out to this nice beach once again. But this time, let's take a microscope with us, and let's sample a little bit of that ocean water and have a look around. Now, it's a little bit difficult to know exactly what life would have looked like during this time. We know what it did, what it lived like, and all these things. But the problem is that fossils usually don't preserve so well. But with a little bit of science background, I came up with a pretty much accurate scientific representation of what the life during this time would have looked like. So here it is. It's very happy because it's an iron bacterium. And this is a great time to be an iron bacterium, because iron bacteria eat iron, as the name suggests. And they gain energy by this, and then they poop out rust. So it's a very nice lifestyle that they're having. You eat iron, you poop out rust. And the great thing is that there's an ocean filled with iron. Remember the ocean that we saw? It had a little bit of a greenish tint. That's what happened if there's a lot of water with iron in it. So this little iron bacteria is living in paradise, and you see it knows that because it's smiling. So this iron bacterium is very happy. It also has some rather interesting neighbors. This is one of the neighbors. It's a purple bacterium. I know the name is quite obvious. And the purple bacterium is quite interesting. It's not just pretty, it's also a true innovator, because it came up with a novel way to get energy out of the environment. It's using sunlight, a process called photosynthesis. You might be familiar with this because plants also do this, but this iron bacterium is doing it a little bit differently, because the one that you know produces oxygen, but the iron bacterium does not want anything to do with oxygen, so it has like a little bit of a different system going on where it can still gain energy by this. Now, they also have another bacterium living there. This is a cyanobacterium. And cyanobacterium, also an innovator, has come up with this process that you're more familiar with, using sunlight and producing oxygen, the photosynthesis that we all know and love. Now, the problem about this is that this cyanobacterium is a little bit of a bad boy in this world. Because the problem is, this world is pretty much devoid of oxygen. And everyone is very happy with that state of affairs, because oxygen is very reactive. Oxygen is a very aggressive chemical. It has this thing that it does, and it binds very quickly to everything else, and no one likes it. It binds to cell walls, it binds to everything that you would like to eat. No one likes it. So the cyanobacterium itself even has a little bit of a problem, because it's like recklessly producing oxygen, and that oxygen is actually dangerous to itself. However, luckily, that recklessness is not directly dangerous, because the cyanobacterium lives on a big planet. That big planet is filled with rocks, and oxygen very happily binds to rocks. So the Earth can absorb all the oxygen that the cyanobacteria are producing. So everyone can still very much live in paradise. However, as we all know, paradises are not meant to last forever. And this process has been going on for hundreds of millions of years. And by now, the rocks have pretty much absorbed all the oxygen that they could have ever absorbed. So what is happening now? You guessed it, the oxygen is starting to accumulate in the environment. It's starting to build up in the water, it's starting to build up in the atmosphere, and that is bad news for pretty much everyone around. Remember the happy iron bacterium? Well, iron bacteria, they survive by eating iron and pooping out rust. Now the problem is, if an iron bacterium lives where oxygen is around, oxygen is even faster at turning iron into rust. So basically, from the perspective of the iron bacterium, the oxygen is eating its food faster than it can itself. That is a very bad state of affairs. And the purple bacterium from before is not too happy about this whole thing either. Because the problem is, if you need the light from the sun to survive, you cannot hide into underground shelters. Now, the last place where oxygen would go is underground in the sediments of the ocean. So if you want to hide from oxygen, that's the place to go. You go to your underground shelter. But if you need the sunlight, you cannot hide in a shelter. So what can a purple bacterium do? So this is a challenge that cyanobacteria are presenting everyone around with it. It's, as I said, it's quite a bad boy. It makes everyone quite unhappy. Now, the problem is, if you don't want to die in this world, what can you do? Because everyone around you is pretty much dying. You have oxygen in the water, you have oxygen in the atmosphere. You see all these nice patches of the gelatinous microbial walls that you saw before are all fading away. Everyone is hiding, seeking shelter as fast as they can. The iron bacteria are very lucky because they can hide in the sediments and all like somewhere in underground aquifers, because all they need is iron-rich waters. And you can find iron-rich waters underground where they're streaming out from rocks. Purple bacteria, not so happy, because they are living out in the open where there's sunlight. So basically, the cyanobacteria, the reckless bad boys of ancient Earth, have turned this planet that was teeming with life into a post-apocalyptic hellscape. Planet Earth, and most life of it, is dying. It's a mass extinction of truly global scale. Life has found a way to almost lead itself to the brink of extinction by causing a global climate change. Sounds a little bit familiar, right? Now, however, what we all know is that this is not the end of the story. Although the events that turned out at the end of the Archean were pretty dramatic and a pretty large global climate change of apocalyptic dimensions, were of course not the last chapter of life on Earth, because all of us are living proof. It was actually just sort of a midlife crisis for Earth. And of course, what we all know is that we all breathe oxygen we actually needed to survive, because while oxygen is very aggressive and reactive, it's also a great carrier of energy. And if there's enough oxygen around, maybe whole new metabolisms and way of life could develop that used oxygen as a source of energy. However, of course, this is not the view of everyone else who would have lived on this ancient Earth. For them, it basically felt like the world was ending. The warm, balmy paradise that they knew from the history was gone forever. From now on, there would be oxygen in the air, the atmosphere itself has turned poisonous, and they became a planet of survivors. This series of events is also called the Great Oxidation Event. Another nice name for it is the oxygen catastrophe, which I think is carries the whole sense of dramatic events that happened, and did not even turn the atmosphere poisonous for most of the life around at this time. It led to even greater changes. Do you remember the third planet that we went to, this snowball-covered ice world? This is what happened to Earth shortly afterwards, because all the oxygen in the atmosphere led to a global cooling of the world. So not even had the atmosphere become dangerous and all of life had to somehow scatter around for survival, they were suddenly also living on a world that was completely covered by ice, an even greater challenge, especially for the poor life that depends on the sunshine, somehow has to survive under the ice. It is very difficult for us to imagine how life could have survived post-apocalyptic events like this. But of course, we all know it did, because we are still around. Now the question is, if we now take all this perspective back to the planet that we live on, what can we take from this? The interesting thing is that all of these actors, all of the characters that we met before, are still alive today. And I meet them actually very often when I go out to these extreme environments where nothing else will survive. For example, when I go and study the salt lakes in the Atacama Desert, I find very nice, thick, gelatinous mats. And they are exactly our heroes from before. The cyanobacteria and the purple bacteria are no longer arch enemies. They've actually found a nice way to collaborate. The cyanobacteria have found a way to adapt to the oxygen they produce. So they build the top layer. And the purple bacteria, which cannot really endure oxygen, hide underneath. They can still get a little bit of sunlight that filters through, so they can still survive and eat, but they're shielded from oxygen from the very ones who caused it in the first place. And the iron bacteria from before, they have gone underground. For example, in this place. This is in Western China. And there is a part where water from underground comes up and spills out to the surface and is filled with iron bacteria who are happily living underground. You can even see the red color, that's all the poop, the rust that they poop out. So they are still around, they're still surviving in a world that is no longer paradise, but that is very much a post-apocalyptic world. The question is, what does this tell us about if we want to go, for example, to look for life on Mars? Well, personally, it makes me quite optimistic that we might find life on Mars, because Mars has undergone even greater events than Earth had to face during its midlife crisis. Because Mars, it looks like it once had water on its surface, and then all evaporated over time. It lost its atmosphere, it cooled dramatically. But as we know about the story of survival on Earth and about the toughness and resilience of microbial survivors, astrologists like myself are a little bit optimistic that maybe life even found a way to survive on a today barren world like this. Maybe it also went underground somewhere and found a way to still tough it out against all the odds. Now, if you look back about the story of life on our planet, about all the changes that Earth has gone through, what is something that we can take away from our current times? The challenges that we face ahead are not quite as dramatic as those that the microbes of the ancient time had to face. We also now know that we are not by far the first species that has caused the entire climate of the planet to change, that is causing a mass extinction. The cyanobacteria are the real innovators who came first. But the cyanobacteria also found a way to adapt to all the change that they brought on. Oxygen at first was dangerous to them as well, but now they adapt, and they are doing quite well for themselves. And all the microbes that somehow had to survive in the suddenly changed landscape, they also found a way to survive. Because the story of survival is an ongoing one on this planet. And we are all the children of survivors. The genes that we carry were brought on through billions of years of evolution and have faced all kinds of challenges going ahead. So what does this mean for us? What can we learn from those humble microbes who are faced with the end of the world? Is there some kind of lessons that we can take from this? Well, personally, I would say that if we are faced with the different ways to deal with the challenges ahead of us, that we know that the end of the world might not be ahead, but definitely a dramatic change of the world is ahead for us. So if you ever choose how to face it with denial or despair, I want to encourage all of us to maybe take it ahead at those tough microbes that we saw before. Because I think the optimist attitude to the end of the world is to see it as the end of one world and the start of a new one. And maybe we can take a little bit of the wisdom of those microbes, because they did not see the end of the world as the end of their own story. They saw it at the end of one chapter and the beginning of a new one. And I think that is very much the attitude that we can also take on ourselves as we start and look towards our own future. Thank you so much.